Consolidating code using functions, part 2. In part 1, we created the updateScreen function. And we pulled the parts that were going to move the lemon and the lime to a random location, which was being done in 2 different places. We moved it into one common function. That function was declared very much like a variable, but instead of the word var, it uses the word function, followed by the name of the function. And with functions, then there's the definition of the parameter list. In this case, there are no parameters, so it's open parentheses, close parentheses. And then a value of a function is contained within an open curly brace and the closed curly brace. Now, this function captured code that was identical in both sections. We're going to look at the next level of consolidation. In our game, we had an on-event handler for the lemon and one for the lime. Now, when you hit the lemon, your score would go higher. So there was the code for potentially increasing the size. That code is also code that affects properties on the lemon and the lime. So that's also a candidate for pulling out of the event handler and putting into the updateScreen function. Now, why would you do that? What we're doing now is we're beginning to partition the functionality code into 2 types of functions. If we look at the lemon event handler, it's going to play a sound, it's going to update the score. And there's one more piece here. Look at that. The score label. The score label is updated here. That too could be moved into our updateScreen. We'll put it at the end. Now here's a question you might say. Well, actually, here the score label does change because the score label includes both the score and the lives. So when we hit a lemon, the score is going up. When we're hitting a lime, the lives are going down. But both things, we're going to change that label. And so by putting that code down here in the bottom in the updateScreen, update the screen text, we can remove it from the 2 event handlers. Now they're getting much shorter. So for a lemon, we're increasing the score, and then we're going to update the screen. And we're going to play a sound unique to that. On the lime, we're going to decrement lives. We're going to update the screen. Now there's one last piece we're doing here, and this is specific to lives in the game when you run out of lives. So lives equals 0, set the screen to the start screen, and set property. Now this is also one you could consider putting down here. Now why would this be? Or it's like, well, it's not common code. So the reason you might make a change like this is that you have different objects that are getting the events, and the event is only going to change what we call the state property. In this case, it's globals. So a lemon's going to increase the score, a lime's going to decrement lives. And if you add new things to the game, some things might affect both scores and lives. You might be able to get a new life. Or maybe after getting every 10 scores, when you get another score and it goes over like unit 5, 10, 15, you might add a life there. And so by separating the code that updates the display from the code that's simply updating variables, you now make it so that it's easy to add event handlers for new objects. It's also easier to see all the code related to doing things like changing the size, relocating the objects, changing the score label as a whole, and also deciding when the level of the game is going to change. In this case, the only level we have is basically you lose and going back to the start screen. So making a function is good for consolidating identical code. It's also a good technique to pull code that has a related functionality. In this case, updateScreen is doing all the work related to moving objects, changing text, and changing other properties, whereas the event handlers are only changing the core state variable of the system. That is, in essence, one of the core reasons you end up making functions, to consolidate code for identical code and for similar or related type of operations. That's Computer Science Principles, Unit 4, Lesson 9, Exercise 5.